There was a time when one engine dominated North American highways so completely that it became almost invisible. It wasn't the loudest. It wasn't the biggest. It wasn't even the most powerful. Yet if you stood beside an interstate in the United States or Canada during the 1990s, chances were good that 1 out of every 3 heavy-duty trucks passing by was powered by the same engine. The Detroit Diesel Series 60. For thousands of drivers, it was more than an engine. It was a trusted partner that started on freezing mornings, climbed mountain grades without complaint, and often accumulated 1,000,000 miles before requiring a major overhaul. Fleet owners praised its fuel economy. Mechanics appreciated its logical design. Drivers admired its smooth power delivery. But if it was so successful, why did production eventually end? Why did an engine that transformed the trucking industry disappear from new trucks? Was it simply replaced by something better, or was it pushed aside by forces beyond the control of its engineers? To answer those questions, we have to travel back to the late 1970s, when the American trucking industry faced one of its biggest turning points. The decade had been difficult. Fuel prices had surged after the oil crises. New emissions regulations were beginning to reshape engine development. At the same time, trucking companies demanded greater efficiency to remain profitable. Traditional two-stroke diesel engines, which had helped build Detroit Diesel's reputation for decades, were reaching the limits of their design. Detroit Diesel knew it needed something entirely different. For years, the company had been known for engines like the famous 6-71, 8V71, and 8V92. These rugged two-stroke diesels earned legendary status in trucks, buses, construction equipment, military vehicles, and marine applications. Their distinctive high-pitched exhaust note became instantly recognizable across North America. Yet by the early 1980s, the industry was changing rapidly. Competitors such as Cummins and Caterpillar were investing heavily in modern four-stroke diesel technology. These engines promised better fuel economy, lower emissions, and greater durability under increasingly demanding operating conditions. Detroit Diesel faced a critical decision: continue refining its aging two-stroke designs, or risk everything by creating an entirely new engine from the ground up. The company chose the riskier path. Development of the Series 60 required years of engineering work and enormous financial investment. Instead of adapting an existing platform, engineers designed a completely new inline six-cylinder diesel intended specifically for the future of heavy-duty trucking. When the Series 60 entered production in 1987, it immediately stood apart from nearly every competitor. Its basic architecture was deceptively simple: an inline six-cylinder layout with a cast-iron block and cylinder head. 4 valves per cylinder improved breathing compared with many earlier designs. Wet replaceable cylinder liners made rebuilding more practical, allowing worn liners to be replaced without machining the block. This feature reduced overhaul costs and extended engine life. Early versions displaced 11.1 liters, while the more famous 12.7-liter version soon became the industry's benchmark. Later, displacement increased again to 14 liters to satisfy demand for higher horsepower and torque. Depending on configuration, horsepower ranged from roughly 330 to over 500 horsepower. Torque output stretched from around 1,250 pound-feet to approximately 1,850 pound-feet in later high-output versions. Those numbers were impressive, but they weren't what truly changed trucking. The real breakthrough was electronic engine management. Today, electronic controls seem ordinary. Modern vehicles contain dozens of computers constantly monitoring engine performance. In the mid-1980s, however, this approach represented a dramatic shift for heavy-duty diesel engines. The Series 60 became the first widely successful Class 8 truck engine designed from the beginning with fully integrated electronic controls. Instead of relying entirely on mechanical fuel injection timing, the engine's electronic control module, commonly known as the ECM, continuously monitored operating conditions. Sensors tracked engine speed, coolant temperature, boost pressure, throttle position, and numerous other inputs. The ECM then adjusted fuel delivery with remarkable precision. For drivers, the technology was largely invisible. But its effects were obvious. Throttle response became smoother. Cold starts improved. Fuel delivery became more consistent. Diagnostic information could be retrieved electronically, reducing troubleshooting time. Fleet maintenance shifted away from guesswork toward data-driven decisions. Fuel economy also improved. Even a modest gain in miles per gallon translated into substantial savings for large trucking companies. A fleet operating hundreds of tractors could save thousands of gallons of diesel annually simply by reducing fuel consumption by a small percentage. Over several years, those savings became millions of dollars. Fleet operators noticed. Orders increased. The Series 60 quickly earned a reputation as an engine that balanced performance with operating costs better than many competitors. Drivers noticed something else. Power arrived differently than with older engines. Instead of constantly chasing high engine speeds, the Series 60 produced strong low-end torque. That meant fewer gear changes, smoother acceleration, and less driver fatigue on long highway runs. Maintaining speed over rolling terrain became easier because the engine could pull effectively without constantly downshifting. Long-haul operators appreciated another characteristic: reliability. Properly maintained Series 60 engines routinely accumulated extraordinary mileage. Reaching 1 million miles before a major overhaul became realistic for many fleets. Some engines exceeded that milestone with disciplined maintenance, regular oil analysis, quality filtration, and timely repairs. Of course, no engine was perfect. Electronic systems introduced new challenges. Early technicians had to learn computer diagnostics alongside traditional mechanical repair skills. Sensor failures could create problems unfamiliar to mechanics who had spent decades working exclusively with mechanical fuel systems. Some drivers initially distrusted electronics altogether. They worried that computers would be harder to repair on the roadside than mechanical components. Those concerns were understandable. Yet as experience accumulated, confidence grew. The electronics proved remarkably dependable, and the benefits usually outweighed the occasional complexity. Instead of replacing reliability, digital control enhanced it by helping the engine operate more consistently under changing conditions. The timing could hardly have been better. The American trucking industry itself was evolving. Deregulation had intensified competition. Companies searched relentlessly for ways to lower operating costs while transporting more freight across longer distances. Every improvement in fuel economy, uptime, or maintenance efficiency translated directly into a competitive advantage. The Series 60 seemed almost purpose-built for that new reality. Within only a few years, it became one of the most influential heavy-duty diesel engines ever built. And yet, even as its reputation continued to grow, forces outside Detroit diesel were beginning to reshape the future once again. The engine that appeared nearly unstoppable was about to face challenges no amount of engineering alone could completely overcome. By the early 1990s, the Detroit Diesel Series 60 was no longer simply another engine option. It had become the benchmark by which many heavy-duty diesel engines were judged. Truck manufacturers, fleet managers, and independent owner-operators all recognized the same qualities: dependable performance, impressive fuel economy, and an ability to cover enormous distances with proper maintenance. Production numbers reflected that success. Hundreds of thousands of Series 60 engines entered service across North America. They powered long-haul tractors, vocational trucks, buses, motor coaches, and a variety of commercial applications. For many fleets, choosing the Series 60 became the safest business decision because its operating costs were predictable and replacement parts were widely available. Much of that reputation came from an engineering philosophy focused on durability rather than unnecessary complexity. The cast iron block was exceptionally rigid, helping the engine withstand years of heavy loads and continuous highway operation. Wet cylinder liners allowed technicians to rebuild worn engines efficiently without replacing the entire block, significantly reducing overhaul costs. A gear-driven accessory arrangement minimized maintenance on critical components, while the cross-flow cylinder head improved airflow for more efficient combustion. As the engine evolved, Detroit Diesel introduced refinements that kept it competitive. The original 11.1-liter version eventually gave way to the more popular 12.7-liter model, which became the engine most drivers remember today. Later, displacement increased again to 14 liters, providing additional horsepower and torque for heavier freight and more demanding applications. Depending on configuration, later models produced well over 500 horsepower and as much as 1,850 pound-feet of torque. More importantly, much of that torque arrived at relatively low engine speeds. Instead of revving aggressively, the Series 60 delivered smooth, usable pulling power exactly where drivers needed it most. That characteristic changed the driving experience. Long grades could often be climbed without constant shifting. Highway cruising became quieter because the engine maintained speed at lower revolutions. Reduced engine speed also lowered wear, improved fuel efficiency, and contributed to the engine's reputation for longevity. Inside the cab, drivers appreciated another advantage that rarely appeared in sales brochures. The engine simply felt refined. Compared with many earlier heavy-duty diesels, vibration levels were lower. Power delivery was smoother. Electronic controls managed fueling with remarkable consistency, reducing hesitation and improving throttle response. After spending 10 or 11 hours behind the wheel, those small improvements made a noticeable difference in driver comfort. Fleet maintenance departments were also entering a new era. The electronic control module did far more than manage fuel injection. It continuously monitored engine operating conditions and stored valuable diagnostic information. Instead of relying solely on symptoms reported by drivers, technicians could retrieve fault codes, examine engine data, and identify developing problems before they became catastrophic failures. Preventive maintenance became increasingly data-driven. Oil analysis programs expanded. Electronic records tracked fuel economy, idle time, engine hours, and maintenance intervals. The Series 60 fit naturally into this new approach, allowing fleets to maximize uptime while controlling repair expenses. Its influence extended beyond the engine itself. Competitors quickly recognized that electronically managed diesel engines represented the future. Manufacturers accelerated development of their own advanced control systems, and the heavy-duty trucking industry entered an era where software became almost as important as mechanical engineering. In many ways, the Series 60 helped define what a modern diesel engine should be. But while engineers celebrated these achievements, another challenge was growing larger every year: emissions regulations. Throughout the 1990s, governments around the world became increasingly concerned about nitrogen oxides, particulate matter, and other pollutants produced by diesel engines. In the United States, the Environmental Protection Agency introduced progressively stricter standards that required manufacturers to reduce emissions dramatically over relatively short periods. Meeting those standards was extraordinarily difficult. Improving fuel economy often increased combustion temperatures, which could raise nitrogen oxide emissions. Reducing one pollutant sometimes increased another. Every engineering decision involved compromise. Detroit Diesel responded with continuous updates to the Series 60. Fuel injection strategies became more sophisticated. Engine calibrations were revised repeatedly. Cooling systems improved. Turbocharger technology advanced. Every new generation attempted to satisfy emissions requirements without sacrificing the reliability that customers expected. For several years, those efforts succeeded. The Series 60 remained one of the industry's most respected engines while adapting to changing regulations. Yet each regulatory step demanded additional hardware, more complex software, and increasingly precise control over combustion. The engine that had introduced electronic management was now becoming dependent upon it. Then came one of the most significant changes in Detroit Diesel's corporate history. During the late 1980s, the company became part of Daimler-Benz, the German manufacturer known for Mercedes-Benz commercial vehicles. Over time, Daimler increased its ownership and eventually integrated Detroit Diesel into its global truck operations. This relationship brought substantial advantages. Engineering resources expanded. Research budgets increased. Technology sharing became possible between North American and European operations. Detroit Diesel gained access to advanced manufacturing techniques, while Daimler strengthened its position in the North American heavy-duty truck market. The partnership also influenced product strategy. Rather than developing every future engine entirely from scratch, Detroit Diesel increasingly worked within Daimler's global engineering framework. Components, electronic systems, and design philosophies began aligning with international platforms. Meanwhile, the Series 60 continued proving itself where it mattered most, on the road. Stories of engines surpassing 1 million miles became common enough that they no longer seemed extraordinary. Some fleets reported engines approaching 1.5 million miles before requiring complete overhauls, although such longevity depended heavily on maintenance quality, operating conditions, and careful servicing. Mechanics often remark that many high-mileage Series 60 engines failed not because of catastrophic design flaws but because normal wear finally caught up after years of demanding service. That distinction mattered. A million-mile engine was never expected to remain perfect forever. Instead, owners valued the fact that it usually aged predictably. Problems often developed gradually, allowing repairs to be scheduled instead of forcing unexpected roadside breakdowns. Of course, the Series 60 was not without weaknesses. Some operators experienced injector failures, sensor issues, turbocharger wear, or cooling system problems, particularly as engines accumulated significant mileage. Electronic components occasionally failed, and wiring harness issues could create frustrating intermittent faults. Yet compared with many competing engines of its era, these problems were generally viewed as manageable rather than fundamental design defects. Its reputation remained remarkably strong. But as the first decade of the 21st century approached, another wave of emissions regulations loomed on the horizon. These new standards would require technologies that fundamentally change diesel engine design. Exhaust gas recirculation became necessary to reduce combustion temperatures and nitrogen oxide formation. Diesel particulate filters were mandated to capture soot before it left the exhaust system. Eventually, selective catalytic reduction would be required, injecting diesel exhaust fluid into exhaust gases to chemically neutralize nitrogen oxides. Each system added cost, weight, complexity, and new engineering challenges. Maintenance intervals changed. Operating procedures evolved. The entire philosophy of diesel engine design shifted toward emissions compliance as the primary driver of technological development. The question was no longer whether the Series 60 could continue evolving. The question was whether an engine whose basic architecture dated back to the 1980s could keep adapting indefinitely, or whether an entirely new generation of diesel engines would eventually take its place. Detroit Diesel faced another critical decision, eerily similar to the one it confronted decades earlier when choosing to develop the Series 60 itself. By 2007, emissions regulations had reached a breaking point for many traditional engine designs. The Series 60 had been updated countless times, incorporating improved electronics, revised fuel systems, and sophisticated emissions controls. Yet the regulatory path ahead demanded even more dramatic changes. Detroit Diesel made its choice. Rather than continuing to modify the Series 60 platform, the company introduced an entirely new engine family, the DD13, DD15, and eventually the DD16. These engines incorporated advanced technologies designed specifically for the post-2010 emissions environment. The DD platform featured common rail fuel injection, improved combustion efficiency, advanced turbocharging, and integrated aftertreatment systems. They represented the next generation of Detroit diesel engineering, built upon lessons learned from the Series 60 but designed for a fundamentally different regulatory landscape. Production of the Series 60 gradually wound down. The final engines rolled off the assembly line in 2011, ending a production run that had lasted nearly a quarter century. By that time, well over 1 million Series 60 engines had been built, making it one of the most successful heavy-duty diesel engines in history. Yet the engine's story didn't end with the last production unit. Thousands of Series 60 engines remain in service today. Independent repair shops still specialize in rebuilding them. Parts suppliers maintain extensive inventories. Online communities share maintenance advice, troubleshooting tips, and repair experiences. For many owner-operators and small fleets, a well-maintained Series 60 still represents reliable, affordable transportation. The engine's mechanical simplicity, relative to newer designs with complex emission systems, makes it appealing to operators who value straightforward maintenance and proven durability. Some drivers speak of their Series 60 engines with genuine affection, describing them as the best engines they ever operated. Others remember them simply as dependable workhorses that rarely caused trouble and always brought them home. That legacy is perhaps the greatest measure of the engine's success. The Detroit Diesel Series 60 didn't fail. It wasn't replaced because it was inadequate or unreliable. Instead, it disappeared because the world around it changed in ways that required fundamentally different engineering solutions. Emissions regulations, corporate consolidation, technological advancement, and evolving customer expectations all played roles in the transition from the Series 60 to newer engine designs. Yet its influence remains visible throughout the industry. The electronic engine management systems that seemed revolutionary in 1987 are now standard across every manufacturer. The focus on fuel efficiency, predictive maintenance, and data-driven fleet management all trace their roots to innovations pioneered during the Series 60 era. In the end, the Detroit Diesel Series 60 accomplished exactly what its engineers intended. It transformed an industry, proved that electronic controls could enhance rather than compromise reliability, and established new standards for what heavy-duty diesel engines could achieve. For nearly 25 years, it powered the highways of North America with a quiet competence that earned the trust of drivers, mechanics, and fleet managers alike. And perhaps that's the most fitting tribute of all. Not the loudest engine. Not the biggest. Not even the most powerful. Just the one that worked, day after day, mile after mile, for longer than almost anyone expected.